Hello, good day. Now let's take a look at these questions. Let's go through these questions. Here we're asked to find x in the equation 2 log x base 4 plus 9 log 4 to base x is equal 9. Here it would have been better. You see that the base are different, but it's like they are inverse. Okay, here the base is 4 and here the base is x. Here the logarithm is x, here the logarithm is 4. So here we cannot apply multiplication rule here because the base are different. Okay, now all we need to do here, basically, here we have since the base are different, we need to adopt a transformation. The transformation is needed uh, true so that we can make the base look the same. Okay, and this can be done through by one of the law of logarithm, change of base. Okay, now uh, let's change log 4 to base s so that it will be of the form log x to base 4. So we will transform this so that we look like uh, x base 4. Okay, that we can easily do by saying let log 4 to base s is equals to u. And if that is the case, from definition, we can simply say that here this is the same thing as 4 is equals to s raised to the power of u from definition, that the logarithm of a number is the power to which the base must be raised to give that number. Okay, now once this is done, the next step is to take logarithm of both sides to base 4 because we are trying to transform this to look like this. So we look at the left hand side here, which is 4. We change the base to base 4. Okay, so this become log 4 is equals to log s raised to power u base 4. Now remember that log 4 is equivalent to 1. So which is equals to 1 is equals to, now we also transform u back here. This become 1 is equals to u log x base 4. Because we are solving for u, now we divide both sides by log x base 4 and u becomes 1 over log x to base 4. Okay, now in another question, I mean, in case you have question of this nature, all you need to do, you can choose either of this one that you tend to change the base. Okay, if you are transforming this, if you want this to look like this, all you need to do is just say this expression here, log 4 to base s is 1 all over what you have here. Okay, that is the quickest way, but for explanation sake, we'll go through this. Okay, so we have already know that to transform log 4 to base s so that it will look like x to base 4, it should be of this nature, 1 over log s to base 4. Now we put this in our equation and this become, if you look at our, this is the equation 2 log s base 4 plus 9 log 4 to base s equals to 9. So in place of this, we replace it with 1 over log x to base 4. Okay, this becomes 2 log x base 4 plus 9 all over log x base 4 is equals to 9. Here we cannot solve here. Okay, even though that the base look the same now, but we cannot solve because this is a fraction already. Okay, all we need to do is to use an appropriate means to say let log x to base 4 equals p. Okay, or let it be p, and if that is done, this becomes 2 times p plus 9 all over p. 2p plus 9 over p is equals to 9, and this is a fraction. Here we need to clear this fraction by multiplying through by p. So here be p times 2p plus p times 9 over p is equals to 9 times p. And if that is done, this becomes 2p squared plus 9 is equals to 9b. Here we need to move 9b to the left hand side. All we need to do is you can say add minus 9p, add minus 9p to both sides, and this equation become 2p squared plus 9p plus 9 minus 9p equals to 9p minus 9p. So that this becomes 2p squared minus 9p plus 9 equals to 0. Okay. Now, this is a typical quadratic equations. And for us to solve by using factorization, let's test if this expression is factorizable by using this expression b squared is equal to 4ac, where a is 2, b is minus 9, and c is equal to 4. Okay, here if we put it in this expression, this is minus 9 all square is equal to 4 times 2 times 9. You see that both sides are the same. It means that this equation, quadratic equation, is factorizable. And what do you need to do if you are factorizing this expression? You use the term containing the highest power of the unknown, which is a 2p square. You multiply the constant term, which is plus 9. Okay, and if that is done, we see that the product of a square times c become 18p square. Now let's find all the factors of 18p square. One of the factor is 18p times p, that will give us 18p square. 2 can still go 2p times 9p, that will give us 18p square. 3 can also divide 18p square, so it's 3p times 6p give us 18p square. Now we are going to look for an expression that can replace minus 9p. So if we add this expression or subtract it, will give us minus 9p, and at the same time, if we multiply the two numbers or the two expressions, they will also give us 18p square. Okay, and from this factor, from all the factors given so far, it is 3p and 6p that can conveniently fit in. So minus 3p minus 6p, that will give us minus 9p. Then minus 3p times minus 6p, that gives 18p square. Okay, so we will replace the middle term minus 9p with minus 3p minus 6p. And if that is done, the expression becomes 2p squared minus 3p minus 6p plus 9 equals 11. Okay, now we need to factorize this. We look at this expression, we put it in bracket here. The shorting factor here is p, open bracket 2p. The shorting factor of in 2p squared minus 3p is just p. So p is factor out. This become 2p minus 3p close bracket. Now if you are looking at, if you look at the expression minus 6p plus 9, the shorting factor there is minus 3. This happened because this expression here 2p minus 3p, they must look exactly with like the expression containing the term minus 6p plus 9. So here the shorting factor here is minus 3, open bracket 2p minus 3p close bracket equals 0. Okay, then if you pick p minus 3p into this bracket, here you see the common factor here 2p minus 3p, 2p minus 3, you factor it out, the expression become p minus 3 into 2p minus 3 equals 0. So from the quadratic equation, either 3p minus either p minus 3 equals 0 or 2p minus 3 equals 0. Okay, therefore p is equal to 3 or 3 over 2. Now, but we also were aware, initially we said that from this part we said we said let log x to base 4 equals to p. Okay, we have to return to that so that to obtain the value of x, okay, we say let log x to base 4 is equals to p. From definition 2, we can also say that s is equals to 4 raised to the power of p, because from definition we said the logarithm of a number is the power to which the base must be raised to give that number. So now for us to obtain our x, we say when p is equals to 3, s will be 4 raised to the power 3, that is 64. Now when p is equals to 3 over 2, we could say that s is equal to 4 raised to the power 3 over 2. And if you simplify this become 4 is the same thing as 2 raised to the power 2 times 3 over 2. 2 go with 2, and we'll be left with 2 raised to the power 3, and s is equal to 8. Okay, so s is either 8 or 64. Okay, these two solutions, they are, they fit into the equation. Okay, we can also check to see if our expression is correct. Okay, let's check. 2 log x base 4 plus 9 log 4 base x, when s is 8. When s is 8, you see that this whole logarithm, 2 log 8 base 4 plus 9 log 4 base 8. So here, if we assume that log 8 base 4 is equals to d, and log 4 base 8 is equals to e, from definition here, 4 raised to the power d is equals to 8, and 8 raised to the power e is equals to 4. Now, applying indices here, 2 raised to the power 2d is equals to 2 raised to the power 3, and then you equate powers. So that 2d is equals to 3, and d is equals to 3 over 2. Similarly, 8 raised to the power of e is equals to 4. Then 2 raised to the power 3e is equals to 2 raised to the power 2. So that e is equals to 2 over 3. Now, if this e and d are substituted in this expression here, you say this becomes 2 times, because the whole expression of log 8 to base 4 is 3 over 2 plus 9 times log 4 to base 8 is 2 over 3, and you see that 3 plus 2 is equals to 9, which satisfy this equation. Okay, so similarly, if you try 64, when s is 64, you see that the result is unique and the same. Okay, please, this is how to resolve a quadratic equation if the base are not the same, if the base are inverse. So please, all you help me subscribe to my YouTube channel, and also share this uh, uh, video if you like them. Have a nice time. See you in my next virtual class.